Hello everybody, thanks for being here. Today we have some geometry to look at. This is the stick box that many Montessori classrooms have, and I highly recommend it. It's used a lot, it's useful, and the children like it. Let's see what condition it's in. Here's the big reveal. Not bad, not too bad. In this box, we have mostly what we call the sticks, and they are kind of building sticks with little holes in them. We've got some thumbtacks, some note cards. We've got some little characters we teach with. Let me get one of them out. Kind of some old-fashioned looking pictures there. We talk about convergent, divergent, parallel lines, that sort of thing. Then we have a whole bunch of brads or fasteners. And this is great for teaching lots of things, but I'd say we teach a lot of triangle. We do a lot of triangle work with it. You could make quadrilaterals and all sorts of things, but one of the main things, at least I teach it with, is learning triangles. It's really hard for children to keep straight, identifying triangles by sides and by angles. So by angles meaning acute, obtuse, and right, and by sides, equilateral, isosceles, and scalene. Well, so if you ask them to identify a triangle, it's hard for them to figure out which two of those words, two of those adjectives go with that triangle. So you can do this in a lot of different ways and different layers. I'm going to show a couple. So you kind of use the brads to attach these sticks. Well, I'm using two sticks that are the same length, and that's a big clue about what kind of triangle I'm making. Perhaps you can, if you wanted to, in the comments section, you could put what kind of triangle I'm making down before I say. If you can see, let me try to hold it better. I'll hold it closer in just a minute here. Well, hopefully you can kind of see that. So, ideally by the end of third grade, we would want children to be able to identify this triangle with two adjectives, something about its angles, something about its sides. Well, hopefully you've had your chance to sort of think about it, comment if you want. Angles, let's look at them. Well, there's a small, sharp angle, that's acute, and acute. They would have already studied acute angles. Well, if all three angles are acute, the whole triangle is called an acute triangle. This is an acute triangle. Okay, let's see, what else? What about sides? Well, like I was saying, two of the sides are the same length, one's different. Well, what kind of triangle has two sides the same? Isosceles. So this triangle can be identified as acute isosceles. Well, again, those terms might be hard for children to keep track of, but the more they practice with this, the more they start to see, oh, well, these are the same color and the same length. Well, if two of them are the same length, you start to realize, that, hey, every time that happens, every time I'm building triangles, if two are the same, then it's isosceles. Now, spelling that word is a challenge, even for me sometimes. But that's okay, something else to work on. So then you might want to say to children things like, well, can you make an equilateral triangle? And sometimes they get silly, they like to try to be kind of funny and do the smallest or the biggest triangles, and that can be a little bit of a struggle, at least for certain things to look real great. But Usually I'd say most second graders, maybe first graders, but second graders and third graders could pretty quickly put together the idea that the equilateral, lateral meaning line, equa meaning equal, just means it has 3 equal lines. And so that would probably not be very challenging for most of the children in the class, after you've been studying it, of course. So it doesn't matter which size they want to make their equilateral triangle, but they make it. And then what's typical is they take what they've made and either on poster paper or into their notebooks, they trace it and then they write equilateral triangle. Now, again, if they're in third grade and they need and want the challenge, you could say also, well, what about angles here? Oh, acute, 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 acute. It's acute equilateral. And so they could write both of those adjectives to describe this triangle when they're ready for it. So they really enjoy sort of the tactile way that you work with this. Sometimes there's, like I was saying, there's lots of different ways to learn and teach with it. I'd say it's typical to say, have them try to make all those types of triangles and to trace and label them. But, maybe you do 3 one week, 3 the next week. Maybe it depends on how careful and neat they're being. What if we had 3 different sizes? Let me make this one. I'm sure you get the idea. I'm not totally sure where to get a stick box from. We get a lot of our materials from a company called Montessori Outlet because they have pretty good quality stuff and they have more fair pricing. Some of the Montessori materials can get pretty pricey, and Montessori Outlet has done a nice job of keeping prices more reasonable. Well, what do we have here? Well, all 3 sides are different lengths, so that sounds like a scalene triangle. And this angle up in this corner, I don't know if you can see, is obtuse. So it's an obtuse scalene triangle. That's kind of cool. They also love to do this as a partner work. It's kind of nice when they do it as a team. They can quiz each other. They can try to guess the other person's triangle, that sort of thing. So it's highly useful. I highly recommend it. I think if you're teaching geometry at all to children, I don't know, maybe 5 to probably 10 or 11, using this is a great material to use. Like I said, you can teach different types of lines. You can do quadrilaterals. You could make different polygons. You could make a pentagon or hexagon or so on. I'd say I don't typically do that with the stick box, but you certainly can, and I think it'd be great to do that with. There's a lot of art extensions. Children could color things in. They could connect the vertices in a polygon, something like that. They could maybe make fractals. There's a ton of possibilities for working with that. So anyway, that's a basic introduction to the stick box. I hope you guys enjoy this sort of content. I hope it's helpful and informational. Thank you so much for watching.